Hello everyone, my name is Haikun Xu. I'm a senior material science engineer at Advanced Drainage System. ADS is a manufacturer of plastic products for stormwater management systems. Today I'm going to show you around the material science lab I work in and the processing and testing equipment we have so far. And also I will show you what a compounding extrusion trial looks like and the nuts and bolts for R&D experiment. At ADS, we process a lot of recycled plastics. We're actually one of the largest plastic recyclers in North America. Last year, we recycled over 500 million pounds of plastics, and most of them were used in our drainage pipes that have a service life of at least 50 years. But it comes with a lot of processing challenges. Because of the large variety of sources, some plastics are really hard to process. So the material science team must come with a solution, in this case an additive technology, to deal with the processing challenge. Today we're going to study a lubricant also made of recycled plastics to ease the processability of a certain formulation. We're going to study the process benefits. In specific, the energy cost reduction, the torque reduction, melt temperature and melt pressure drop, and whether it has any negative effects on the process. Basically, we're quantifying the process benefits of this additive. Any extrusion trial comes with a test plan. So our plan is to test 4 formulations, and we're going to record the baseline process data, which are our control samples. And then we're going to introduce the additives in different formulations at different ratios. Record the process data change, collect enough compound samples for further evaluation. Next, I'm going to explain a little bit more in detail of what a compounding trial involves. Based on your formulation, you may have different number of continuous gravimetric dosing feeders set up to dose the material into the extruder. Compounding screws are like Lego blocks that can be configured in a way to suit your specific process. Typically, you have 3 types of screw elements. Convey elements have different pitch length to give you different conveying power to move the materials forward. Kneading elements have kneading discs of different staggering angles and width to promote melt splits and elongational shear. Mixing elements can be kneading elements or tooth mixers or other type of low shear mixers to give you the optimal intensity of mixing. Once the materials are in the screw, the frictional heat and conduction heat from the barrel melt the plastics. The materials go through a melting section, a mixing section, and typically a degassing section before the pumping section. Once the melt exits the extruder, it can be a strand die in this case because we're pelletizing. The strand gets cooled in the water bath and then conveyed into a pelletizer that have rotary knives to cut the pellets into a certain length. Now you understand the whole compounding process. What happens next is we're going to test these compound samples and review the process data. It comes down to 2 parts. We want to have enough process benefits to qualify the additives. However, we don't want to have any performance issues with additives. If everything looks good and promising, we will run a scale-up trial on a larger pilot extruder or on a production line. In terms of the material property test, we have an Instron machine that can test tensile, flexural, and compression strength of the materials. We also have instrumented Izod impact tester for mechanical properties. For thermal properties, we have DSC and TGA to study the melting point, glass transition temperatures, anti-oxidative properties, and compositional information about the compounds. We can use a DMA to study the long-term or cyclic response of the material. We also have a 2 parallel plate rheometer to study the intrinsic viscosities of the material other than the melt flow indexer. For chemical testing equipment, we have FTIR, N9R, and Raman spectroscopy to get the fingerprint of a specific material. For us, we use them a lot for identifying unknown recycled plastics or contaminants in the recycled plastics we receive. As a material scientist, we typically study different formulations, evaluate the short-term and long-term material performance, improve the performance, and lower the costs. Now you have gained some insight of what a typical day at work for a material science engineer look like. If you have any questions, please ask away.